right, let's see how to graph these things today, these things called logarithms. I've been trying to show you guys how a logarithm and exponential functions are related. I want to do so graphically before we get going on this. So over here on this side, I'm going to do everything in red. I'm going to show you, remind you the exponential functions. So remember, it went through the point 0, 1, and then whatever the growth factor was my two primary points that I was checking. So 0, 1, and then this was the point 1b. Okay? Then the domain of this went from everything from negative infinity to infinity, while the range, remember, went from 0 to infinity because it's sitting on the x-axis, which is the asymptote. And it had an intercept of 0, 1. Well, what's going to happen on this is everything's going to flip-flop, okay? What was my domain is now on logarithms going to be my range. And then what was my range is now my domain. The asymptote, it's going to switch from y equals 0 to x equals 0. And instead of the intercept being 0, 1, since we're just graphing the inverse, it is going to be 1, 0. So what does that look like? So I've got 1, 0 right here. So that means that I'm going to have an imaginary line right here that I'm not allowed to cross. And I didn't have this point over here, but I'm going to go ahead and flip this 1b. And it's going to be just some random point b1. And so my logarithm looks like this. I'm going to give you some shortcuts as to some of the stuff I did on it. But one thing I do want you to notice before we get going too far into this is that I did just flip this red line over this imaginary y equals x, and it landed towards the blue line for us. Okay. So first thing I want to talk about today is the fact that this blue line did not cross this vertical asymptote coming down. It is not allowed to go over into the negatives. Okay, so as we saw a couple days ago, there is a domain restriction on this where I can't take log of anything that's negative over here on the negative side of the y-axis. Not only that, I can't even take log of 0 because it's never going to touch this line. And so the first thing we want to do today is find the domain. So when finding the domain, it doesn't matter how nasty of a log function I give you, what I want to do is I want to set up an inequality just with the argument. The argument's what you're taking log of. From there, we just have an inequality. We want to solve for x, and then as always, I want your domain in interval notation. So I'm going to do part A, and then you guys can do part B. So on part A, first of all, I want you to realize we're not using the whole equation here. The only thing that can't be negative is what I'm taking log of. So the only thing I'm taking log of here is this x minus 8. And not only can it not be negative, it can't be 0. So whatever I'm taking log of has to strictly be greater than 0. And I'm going to use that greater than 0 every time. So this -2 right here and the 7, I don't even use any of that. So if I solve this for x, I add 8 to both sides, I get x is greater than 8. In interval notation, x is bigger than 8 is everything that's much bigger than 8, which is everything from 8 to infinity. All right, pause the video, you give part B a go. Not too bad of a problem. I need to get everything on this between 10 and infinity on this. Notice I did not use any of this information up front. I just want to use the argument on that. So let's talk about the main event today. I actually want to get these graphed. I'm going to try to relate this as much to exponentials as I can because for the most part, graphing exponentials went really well this year. So first thing I'm going to do is it says I'm going to draw and label my vertical asymptote. It's going to be right here at x equals 0. Okay. And then from there, I think it's going to be easier to consolidate steps 2 and 3 into a table. Okay. Now, if you remember, back when we graphed exponentials, we plotted -1, 0, and 1 in for x every time. I'm going to shorten that just a little bit. Instead of doing any negatives, I'm going to, again, the whole idea of switching my x's and y's, I'm just going to plot 0 and 1 in for my y's. And I'm going to tell you, every time, this is going to be a 1 right here. And whatever my b is, whatever this subscript, is going to go right here on this side. Draw a smooth curve. And we got domain, range, and isotope that I'm going to be interested in listing out to the side. So let's try this one together. Okay. First up, let's locate my isotope. I might put this off next time, but for right now, it's just right here at x equals 0. So I'm going to make myself a little XY table. I'm going to try not to do hardly any math. I'm going to put 0 and 1 on the Y side every time. Okay. And so what goes on the X side is 1 and 7. So I'm going to plot these 2 points. 1, and then 2, 3, 4, 5, 6, 7, and up 1. And so my graph is going to look like such. And that's full credit. Okay, let's go ahead and identify the domain, range, and isotope. The domain is restricted this time, but my range is going to be -infinity to infinity on every single one of these times. And the isotope is infinity. All right, I think you guys know what's coming. Let's move it around a little bit. I went ahead and switched my numbers on this. I don't think that's going to be too bothersome. Okay. I'm going to hold off drawing my isotope on this one because I'm not sure where it's going to end up. Okay, so I'm going to go ahead and start with my table. And like I said, 1, 0 is always going to be my first point. And then whatever my growth factor is, it's going to go right here. I call it the growth factor. It's my log base. So I'm starting with my points here, and then 1, 2, 3, 4. That's 1, 2, 3, 4. So I can see that how this would bend like the last one. Okay, so if it didn't have that -4 right there, then that's what it would look like. But it does have this -4 right here in parentheses, inside the function, inside the argument, inside the log. So everything's happening to this left and right. So I'm thinking, I should move this thing to the left. Remember, it's opposite. So I'm actually going to move it to the right 4. So both these x's go to the right 4. 1, 2, 3, 4. 1, 2, 3, 4. And not to be outdone, the whole reason I didn't draw my isotope up front is because it is going to move to the right 4 as well. Okay, my domain switched a little bit. As you can see, it's still not going to cross this vertical isotope. So it's going to get really close to 4, but not touch it. Okay. Range is same as always. And then your isotope, I moved it to the right 4. So instead of being at x equals 0, it is at x equals 4. I'm going to pause the video, turn you loose on this one. Go ahead and draw that parent function in there, what you draw before you move it, and then draw your regular one so we can compare both. This time the function moved up 7 units. So I just took it straight up. It's way up there at the top. It should be really easy for me to grade. Just see those 2 points in the right position, and they've been moved up 7 units. Let's try some different transformations on it. The same rules are going to apply on this. First up, I need my points in my table. Okay, well, I can draw my isotope if I want to. I see it's not really moving around anywhere as far as left, right, up, or down. So the isotope's going to stay put at x equals 0 on this one. So I'm going through my point 1, 0. That's a staple on this. It's always right there. Oh, I forgot to put a log on this. Did I forget to put a log base on this? Or do you remember that it's the common base? I don't like to use the common base a lot whenever I'm graphing because it's a very uneasy point to work with. I think if it's on here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, if it did fit on here, it would be right here. Okay, so there's my parent function. So I'm interested in moving those x's. In this case, I'm interested in squishing the x's. Okay, this 1/2 right here is in front, and so it will compress those x's by a factor of 1/2. So everything's going to be half the distance that it currently is from the x-axis. Well, if you're on the x-axis, you're just going to stay home. So this x just barely even moves, but that's all I'm really checking for on this one, just to make sure that just barely moved it down. So this logarithm is super flat the way that it works. Okay, nothing changes down here. No range, even though it doesn't even look like it's hardly going up, it eventually will get up to infinity. Okay, and x equals 0. Great. So you try moving this one around. Oh, I threw some extra numbers in there for you. Don't let those throw you off. And so hit pause, and then I'll graph it while you graph it. If you went ahead and graphed it, that's fine. Let me just kind of work my way to hopefully where you got. Now, on these, I want to start on the inside. I see this +1 right here. Everything's working opposite. Everything's going to move to the right one. So I'm going to take these two x's, move to the right one. Did you get this other x in the right spot? E1? This E is just 2.7 right here. So 2.71 is what I got. I bring it back to the right one. It lands right here. It's really kind of weird. You want to make sure you do each individual movement probably by itself. Right, next up, this 2. Remember, this vertical translation is always last back here. So I'm going to work at this 2 up front. That 2 is going to stretch my graph. It's going to make everything, it's going to make these green x's so they're twice the distance from the x-axis that we currently are. Well, now he doesn't move. And he's just going to move from 1 up to 2. All right, finally, I have my -4 back here. -4 is going to move everything down 4 units. 1, 2, 3, 4. And I'm using the correct x, going off the black x right here. 1, 2, 3, 4. Now, I want you to be careful whenever you graph this. Those 2 red dots don't make a lot of sense. There's a lot of ways you can connect those 2 red dots and get them incorrect. So we have not changed this original shape too much of this blue graph, and I'm still not wanting to change it. One thing I might want to do that would help me is go back and redraw my isotope. And so if I think about which way the graph moved, it moved to the left one. And that's where I want to move my isotope. I moved my green and black x to the left too, didn't I? So let me redraw those real quick. Making it so my red dot is only right here. Glad I picked up on that. And so my final answer graph looks like this. Sorry about that moving. It's supposed to be your problem anyway. So hopefully it ended up here at the end. The last one, we know that we can also do reflections with these, I hope. We'll do this one together. Maybe I won't mess this one up. We've got our staple point, 1, 0. It's not moving. See if I can get in the right spot this time. And then we have our base is 2. So we'll also go to the point 2, 1. These points are kind of close together. Again, let's start on the inside. This inside, this negative, means I'm going to reflect it up, down, or left, right. Let's see, it's on the inside, so everything on the inside moves left, right. So it's going to reflect over the y-axis. So it will land over here where I had those last points. And then there's just one more reflection. I put a negative on the outside on this one as well. So that negative will reflect it over the x-axis this time. It reflects up and down. So that will land here and here. Again, that can be kind of weird which way that those connect. But remember, your isotope did not move on this one. We did not have any horizontal translation. There's nothing being added or subtracted inside this argument. So it's still in the same spot. And hopefully that makes sense. I've got to get closer to this isotope as I draw it. So the only way to do that is still go through these x's and send this graph up the other way. Once again, here's just a review of all your translations and transformations of logarithmic functions. Pluses and minuses that I did in the examples are all discussed right here. And so you need to pause the screening and look at some of this, that's fine. If not, good luck with the homework. And as always, let me know if you have any questions.